Competitive Exam Library YouTube channel. Today we are going to see what is the unit step response. Unit step response of second order system. Second order system with under damped case. So this is the we are going to see. So what is the response of the second order system whenever you are consider the under damped case. So now I am going to take the diagram for the second order system. Here we are already know what is the input will be given for this system and what is the output will be given for this. What is the input will be, here we are giving R of S, and here output will be I am taking as C of S. So what it will be there, we are already know the standard equation, that is omega n square divided by S square plus 2 zeta omega n s plus omega n square. So what we can write, for unit step response, for unit step input, for unit step input, so we have to give the R of S is equals to what we can give, that will be 1 by S. Next R of t will be, that is equals to 1, that is we are already know for t greater than or equals to 0, 0 for t less than equals to 0. Now for under damped, here we are considering for under damped case, for under damped case condition we are considering, we are already know that the zeta range will be 0 less than 1 less than. So the range of zeta will be, we are already know that is 0 less than zeta less than 1. So now we are going to derive the derivation for this value. Let us continue with that derivation, how to do that derivation. So it will take the time to do this derivation, please be patient. Now we are going to take that. So C of S divided by, let us see, C of S divided by R of S is equals to what we can write, that is equals to omega n square divided by S square plus 2 zeta omega n s plus omega n square. This is the function. C of S will be, we can write as R of S into omega n square divided by S square plus 2 zeta omega n s plus omega n square. We are already know R of S will be, that is equals to 1 by S into omega n square divided by S square plus 2 zeta omega n s plus omega n square. From this the derivation will start. So now we have to take, so whenever you have taken this, now we will do the partial fractions for the solving of the, let us consider the partial fractions for the above equation to get the response. Okay, partial fractions to get the response of the, that is the second order response. Now we will take C of S, we can write as, that is equals to omega n square divided by S square plus 2 zeta omega n s plus omega n square is equals to, I am writing it as, here I am sorry, here S is also there, S into you are having. So now we have to do this partial fractions, that is k1 divided by S plus I am considering k2 into S plus k3 divided by S square plus 2 zeta omega n s plus omega n square. So this is the equation I have considered here. So let us consider this is the equation number 2 and this is the equation number 1. Now we got equation 1 and 2. Let us solve the equation 2 for the getting of the time response. Now you make the numerators are equal because the denominators LCM will be same. So we can write it as k into, if you make it k s square plus 2 zeta omega n s plus omega n square plus k2 s plus k3 into s. So because the denominator LCM will be same, the both are will get cancelled. Now I am not doing that. Now we have to equate the quotients. For that equation of the quotients, first I am putting s value, that is s is equals to 0. If I put s is equals to 0, then what it will be, left hand side will be omega n square and right hand side will be k1 here, sorry, k1 into omega n square. So because in each and every term, whenever you keep s is equals to 0, then what will happen? So that is a partial fraction method I am using. Okay, so omega n square will get cancelled. K1 value you are going to get it as 1. So first you consider the value of k will be, what is the value of k? That will be omega n square. Okay, so this is the value of k will be k1, sorry, that is equals to 1. Now let us compare now by comparing coefficients, of s square. So what we can write by comparing the coefficients of s square, that will be k1 plus k2 is equals to 0. So whenever you are comparing that coefficients of s square, k1 we are already know that is equals to 1, and k2 value you are going to get, that is equals to minus 1. So k2 value you got it here, it will be that is minus 1. Now you got k1 value and k2 value. Now we are going to compare the, let us compare coefficients of s. So let us compare the coefficients of s. What you are going to get, that will be k1 into 2 zeta omega n. So you have to compare the coefficients in equation number 2 only, we have to compare, that is will becomes 0. Now we will write 2 zeta omega n, because k1 you already know that is equals to 1, plus k3 is equals to 0. So k3 value what we can write, that is equals to minus 2 zeta omega n. Now you got the values of k1, k2 and k3. So you have to substitute this k1, k2, k3 values in equation number 2. Let us move that further. So let us, I am going to substitute. So now we are going to substitute that value. So substitute C of s is equals to, so k1 value will be got it as 1 divided by s, plus k2 value got it as minus 1. So that will be, so k2 value got it as minus 1, that will become minus s into minus 2 zeta omega n, that is the k3 value, divided by s square plus 2 zeta omega ns plus omega n square. So you take out common as minus, then what you are going to get, 1 minus s plus 2 zeta omega n, numerator we can write, divided by s square plus 2 zeta omega ns plus omega n square. So here C of s you got. Now let us take, this is the C of s, we can write the numerator, see, 1 by s minus s plus zeta omega n plus zeta omega n. I think so there is no wrong, just I have separated 2 zeta omega n as zeta omega n and zeta omega n. Now I am going to separate the numerator. So 1 by s minus s plus zeta omega n divided by s square plus 2 zeta omega n s plus omega n square. Okay, so we can separate just the terms, plus, so we are going to separate, the terms will be separated here. So we are going to do, we can do this zeta omega n divided by s square plus 2 zeta omega n s plus omega n square. So we can do, because just I have separated the numerator as 2 zeta omega n, and zeta omega n, then I have separated the term. Now what I am doing, I am going to add, see, before going to do that separation, we can do this step. See here we can do s plus zeta omega n separated plus zeta omega n divided by, we can write it as s plus zeta omega n whole square, you are going to get, plus omega n square minus zeta square omega n square. See what I have done here, I will explain here. Just I have added, see, for the above step, I will write here, for the above step, what I have done, for above step, add zeta square omega n square, add and subtract. Okay, or add and subtract zeta square omega n square in the denominator, denominator. That is what I have done. Just I have added and subtract the denominator. If you want, I will write clearly here. C of s is equals to 1 by s minus s plus zeta omega n plus zeta omega n divided by s square plus 2 zeta omega n s plus omega square zeta square plus omega n square minus zeta square omega n square. Just I have added. So you can replace this entire term with 1 by s minus s plus zeta omega n plus zeta omega n divided by s plus zeta omega n whole square plus, here you can take out omega n square as common, 1 minus zeta square. So you can do that. Now I think so you have understand very clearly. So that is C of s we got now. So C of s can be written as, that is equals to 1 by s minus s plus zeta omega n plus zeta omega n divided by s plus zeta omega n whole square plus omega d square, because you already know omega d value will be under root of omega n square. So sorry, omega d value will be omega n into under root of 1 minus zeta square. So by having this, just you can do one more thing here. You see here. So now I am going to separate. I will write in that next page. So what we can write, that is equals to C of s will be 1 by s minus s plus zeta omega n plus zeta omega n. Just I am writing what we have written in the last step, by s plus zeta omega n whole square plus omega d square. Now I am going to separate this 1 by s minus, we can write s plus zeta omega n divided by s plus zeta omega n whole square plus omega d square minus, we can write this as zeta omega n. Here I am multiplying and divided by omega d, that is equals to omega d is divided here first, next I multiplied here, omega d divided by s plus zeta omega n square plus omega d square. So after this you can write it clearly. So you see here why I have divided all these things, why I have multiplied, why I divided, why I multiplied, all these things you will understand here. See, because I am having the formulas of this, so I am going to write the formulas, because to get that formulas I have taken all these risks. So I will write the formulas for your clarification purpose. So you are already know cos omega dt value will be s by s square plus omega d square. Whenever you are having e to the power of minus zeta omega nt cos omega dt, what it will become, s plus zeta omega n divided by s plus zeta omega n whole square plus omega d square. This is the formula I want to substitute, that's why I have done all modification. After that you have another formula, that is sin omega d dt, that is equals to omega d by s square plus omega d square. So whenever you are multiplied the exponential term, so what you are going to get, sin omega d dt. So here you are going to get omega d divided by s plus zeta omega n whole square plus omega d square. To do this all modification by substituting this two formulas, I will highlight those two formulas what we are going to substitute here. So these are the two formulas we are going to use for the next step. Okay, so to substitute the two formulas I have done all the modifications. Now I think so you have understand. Now we will substitute that C of s is equals to, that is, sorry, let us take the inverse Laplace. Now we will take the inverse Laplace of C of s. Let us take the inverse Laplace of C of s. Whenever you take the inverse Laplace, then what you are going to get, left hand side C of t will be 1 by s inverse Laplace will be 1, then e to the power of minus zeta omega nt cos omega dt. Just I have substituted this formula. Next minus zeta omega n divided by omega d into, in place of this we can substitute e to the power of minus zeta omega nt sin omega d t. So now I think so you have understand. So you can further simplify, that is c of t will be 1 minus e to the power of minus zeta omega nt cos omega dt minus zeta omega n divided by omega d value you already know, omega n under root of 1 minus zeta square e to the power of minus zeta omega nt sin of omega dt. So now we have separated. So omega n will get cancelled. So final answer we can write, that will be c of t is equals to, what we can write, 1 minus e to the power of minus zeta omega nt cos omega dt minus zeta divided by under root of 1 minus zeta square into e to the power of minus zeta omega nt sin of omega dt. So this is the equation number 3, I think so. So from this equation you take out common, c of t can be written as 1 minus e to the power of minus zeta omega nt divided by under root of 1 minus zeta square. I have taken out common. Then what we can write, the first term will become cos omega dt into under root of 1 minus zeta square plus zeta into sin omega dt. So here you are already know what is the sin theta. Sin theta value we are already know from the triangle 1 minus zeta square, and cos theta value we are already know, that is zeta. You substitute that, then what you are going to get, c of t will be written as 1 minus e to the power of minus zeta omega nt divided by under root of 1 minus zeta square cos omega dt into sin theta plus cos theta into sin omega dt. So if you observe here, you are going to get sin of a plus b formula. What is sin of a plus b formula? Sin a cos b plus cos a sin b. So if you replace that, what you are going to get here, see, we can write it as e to the power of minus zeta omega nt divided by under root of 1 minus zeta square into, replace with that formula sin of a plus b, that will become sin of omega d t plus theta. So now you got, this is called c of t. So c of t will be, this is the response for unit step input. So the response of this unit step input will be, this is 1. So if you want to substitute, you can substitute further values also. So this is a very important formula you have to remember. So another formula is important thing is which one? This one is very important. You have to remember this formula. Okay. So this is the formula you have to remember. Fourth one. So fourth equation is very important for us. Now if you substitute the omega d value as, you already know omega d value as omega n into under root of 1 minus zeta square, and theta value also you already know tan inverse of under root of 1 minus zeta square divided by zeta. So you already know theta value and omega d value. By substituting that, the fourth equation can be written as c of t by e to the power of minus zeta omega nt divided by under root of 1 minus zeta square sin of omega d value we can write it as omega n into under root of 1 minus zeta square into t plus tan inverse of under root of 1 minus zeta square divided by zeta. So just I have substituted omega d value and all those things. Now we are going to get the error signal also. What is the error signal? How we are going to calculate? The error signal will be, we can write it as, so let us write what is the error signal in this case. So error signal will be given by error signal, that is e of t is equals to, what we can write, c of t, sorry it's not c of t, r of t minus c of t we can write, r of t minus c of t, that is the error signal. So here r of t value will be 1 minus c of t value got as 1 minus, you have to substitute all those things, that will be 1 minus e to the power of minus zeta omega nt divided by under root of 1 minus zeta square into sin of, I am substituting it as simply omega dt plus theta only. So then what you are going to get, error signal will be, we can write as e of t is equals to plus 1 and minus 1 will get cancelled. Minus and minus, if you multiply, it will get plus. So E of t value will be e to the power of minus zeta omega nt divided by under root of 1 minus zeta square into sine of omega d t plus theta. So this is the value. So if you want to get the steady state error, so steady state error will be, I will tell what is the meaning of steady state error also in the next videos. Steady state error we can write the time limit will extend to infinite, then we have to substitute this e to the power of minus omega d under root of 1 minus zeta square into sine of omega n into under root of 1 minus zeta square into t plus tan inverse of under root of 1 minus zeta square divided by zeta. So this is the term you have to substitute for calculation of steady state error. That's all in this video. If you like this video, please like, share and subscribe the channel. I hope you understand this entire concept. So if you have any query, please make comment in the comment box. I can reply. Thank you very much.